Welcome to this explainer on industrial maintenance safety. Let's just jump right in. Every plant out there has a safety policy, right? Usually it's sitting in a pristine audit binder on some supervisor's desk, looking very official. But let's be real. Far fewer facilities have a true safety system. And by system, I mean a structural setup that a technician simply cannot bypass when the schedule gets tight and the pressure is on. Today, we're going to explore exactly how to enforce that reality out on the floor.
To set the stage, think about this quote straight from our source material. Maintenance work sits at the intersection of energy, moving parts, and time pressure. I mean, wow. That is such a stark, honest reality. If you've ever spent time on a plant floor, you know this in your bones. We have to empathetically validate the reality of a technician's job. When they're out there turning wrenches, they aren't just casually observing a machine. Their daily routine inherently involves stepping into dangerous, temporary states to get things running again.
And this is exactly why maintenance is the ultimate pressure point for plant safety. Think about the contrast here. During normal operation, everything is guarded just as intended. Operators are working around machines that are in a safe running state. But maintenance work, that completely flips the script. It forces technicians to temporarily defeat the very controls that keep everyone else safe. Guards are literally removed to access a bearing. Energized panels are left wide open. Circuits get tested live just to diagnose a fault. The equipment is mid-repair and, therefore, mid-hazard. None of this is negligence, It's just the nature of the job. The real danger is when these temporary states outlive the task.
Now, what happens when things go wrong in those temporary hazard states? Well, the scale of the fallout is absolutely staggering. $181.4 billion. According to the National Safety Council, that is the total cost of U.S. work injuries for 2024 alone. Just let that number sink in for a second. We're talking about a massive financial hemorrhage impacting the entire economy. So when we talk about industrial safety, we are not just talking about compliance checkmarks.
Let's bring that massive number down to the ground level, right to your facility's bottom line, $48,000. That's roughly the cost of just one single medically consulted injury, once you factor in wage loss, medical bills, and all the administrative overhead. To put that into perspective, that tells us something absolutely crucial. Reliability metrics and safety metrics are practically living on the exact same spreadsheet. A safer plant is fundamentally a more profitable plant. So the big question is, where are we failing? Well, OSHA's fiscal year 2025 data paints a pretty clear picture. Control of hazardous energy, better known as lockout-tagout, drew over 2,500 citations. Machine guarding added almost 1,500 more. These two consistently top the most cited lists for general industry year after year. But why? It's definitely not because the rules are a mystery. Everyone knows what lockout-tagout is. They fail in practice because a paper permit or a quick verbal handoff simply doesn't travel with the work order. The paper stays in the office, the tech goes to the machine, and boom, the disconnect happens right there.
Oh, and if you ever need to get the attention of your operations leadership, just drop this number on them, $165,514. That's how high OSHA penalties can reach right now for a single, willful, or repeated violation. When you realize that preventing just one serious incident outweighs the software and implementation costs for years to come, upgrading your safety systems becomes a total no-brainer.
Which brings us to the core question of this entire explainer. How do we build safety that actually survives a busy shift? How do we move past paper policies that quietly degrade into mere suggestions the second things get hectic? We need structural guardrails. We need systems that hold up when a shift is desperately short-staffed, the timeline is totally blown, and that so-called quick job turns into an absolute nightmare.
To build that kind of bulletproof system, we have to implement 4 specific structural controls. But first, let's just make sure we're on the same page with our terms, starting with lockout-tagout, or LOTO. By definition, LOTO is a procedural control that isolates and verifies a zero-energy state before a tech ever crosses a machine's boundary. We have to clearly separate this from physical machine guarding. Machine guarding is a physical barrier. LOTO is the procedure you use when that barrier has to be removed. Energy isolation failures are literally the highest severity risk in maintenance because technicians are suddenly completely exposed to stored electrical, hydraulic, or pneumatic energy. Okay, let's dive into our first structural control. Control 1, lockout-tagout tied directly to the work order, not abandoned in a binder. Remember earlier when we talked about how paper procedures don't travel with the technician? Well, here is the fix. When your isolation steps, meaning which energy sources, the exact sequence, the verification steps,
are tied directly to the digital work order, the technician physically cannot close the job without confirming they actually did the sequence. This is probably the single highest leverage fix you can make to stop those OSHA citations dead in their tracks.
Now, what happens when a job spans across multiple shifts? That's where Control 2 comes in. Machine guard status tracked as an asset attribute. Guards get removed for access, right? And under intense time pressure, they don't always get reinstalled before the machine restarts, especially during a shift change. By treating the guard status as a mandatory checked attribute on the asset record itself, one that must be verified before the work order closes, you catch those dangerous gaps that are rushed, "Hey man, it's all good, I got it," verbal handoff completely misses.
And that flows perfectly right into Control 3, permit to work structurally integrated with maintenance scheduling. We're talking about hot work, confined space entry, working at height. These all absolutely require permits. But when permits are issued separately from the actual maintenance schedule, you know what happens? Technicians end up doing the paperwork retroactively. They finish the dangerous task, wipe the grease off their hands, and then fill out the permit just to keep the office happy. Integrating the permit into the scheduling forces the safety check to exist before the work even begins.
Our final structural pillar is Control 4, near-miss data feeding preventative maintenance. Actually, scratch that. A recurring near miss isn't just a safety report. It's a maintenance signal in disguise. Think about a guard that keeps vibrating loose, or a valve that constantly sticks under pressure. If you just dump that data into a safety log that nobody in maintenance ever looks at, you're basically just sitting around waiting for a disaster. But if you route it directly into your preventative maintenance plans, you fix the root cause and close the loop before anyone loses time to an injury.
So how in the world do we practically enforce these 4 controls across a massive, chaotic facility? Well, a CMMS, a computerized maintenance management system, bridges this gap. But listen, it only works if you configure it correctly. If you're just using your CMMS as a glorified historical logbook, it's only documenting what already went wrong. Instead, you need to use it to actually gate work order completion. The software physically should not let a tech close the job without isolation and permit sign-offs. It acts as a hard structural barrier that prevents the shortcut from happening in the first place.
Once you have this system humming along, you have to measure it the right way. That means understanding the difference between lagging and leading indicators. So many plants celebrate a falling incident count, which is a classic lagging indicator. But I've got to warn you, a falling incident count alone might just mean your team is underreporting because they're terrified of getting in trouble. Leading indicators, on the flip side, actually prove your system is actively working out on the floor right now.
Let's look at the specific leading KPIs you really should be tracking to empower your plant managers. You want to track the percentage of work orders with a completed isolation sign-off. You want to track the mean time between a near-miss report and the actual corrective action being finished. And you absolutely want to monitor your permit-to-work compliance rate. By pulling these specific metrics directly from your CMMS data, you are measuring true safety success. You're proving the program is functioning on the floor, not just gathering dust on a shelf somewhere.
To actually put all of this into practice, our source material specifically highlights a tool called Man-Win-Win. It's a globally proven CMMS platform designed to provide the exact structure needed for multi-site industrial organizations to enforce these exact controls. It sits right in that sweet spot, more robust than lightweight tools, but way more agile than those clunky, heavy enterprise suites. It gives you the practical, scalable framework you need to turn a static safety policy into a living, breathing safety system.
Which leaves us with a pretty provocative question to chew on. Will your safety policy survive next Tuesday's shift? Seriously, think about it. When 2 guys call out sick, production is breathing down your neck, and a critical machine suddenly goes down. Are you going to rely on an idealized audit binder filled with good intentions? Or have you built a truly resilient, structurally enforced safety system that protects your people no matter the pressure? It is a question worth answering today before tomorrow's shift even begins. Thank you so much for joining me to explore this vital topic. Keep learning, keep improving, and hey, stay safe out there.